Hi there, this is video 3.6. We're going to be multiplying matrices and we're going to use the properties of matrix multiplication. We're not going to have any vocabulary here. So the first thing we want to do is we want to look at how do we multiply matrices. So you can multiply two matrices, A and B, okay, only if the number of columns of A is the same and equal to the number of rows in B. So for instance, if we say A is an M by R and B is an R by M, so remember the first number is always rows, second number is column. We're just making some letters, variables, to represent the numbers. So we're going to say this is A is an M by R and B is an R by M. Now, these two have to be the same. They're equal. The result is going to be an M by M is the size of your dimensions of A times B. So let's go straight into an example and look at it. It says determine whether each matrix product is defined. If so, state the dimensions of the product. Now, you need to write this down again if you didn't write it in class. We talked about the word defined. This is what you need to write down for the video that I'll be checking. So defined just means, does it exist? Is it possible? Number A, can I multiply A times B? Well, let's look at it. It has a 3 by 4 and a 4 by 2. So we use define for addition and subtraction, but if we have an A that's a 3 by 4, and we have a B that's a 4 by 2. So we look, are these equal? Yes, so our result, so it is defined, it can exist, it can be done, and our result is going to be a 3 by 2. So the product of A, B is going to result in a 3 by 2 matrices. Okay, let's look at B. B says if you have matrix A is a 5 by 3 and matrix B is a 5 by 4, can we multiply AB? So we're going to say A is 5 by 3, B is 5 by 4. Are the inners the same? They are not equal. It is not defined. It's not possible. You cannot multiply them. Okay, so stop this, pause the videos, not stop it, and do guided practice 1A and 1B. So how do we find the product of two? First of all, we ask ourselves, is it defined? So in order to multiply matrices, so if I want to multiply A times B, it's going to equal to AB. What you're going to do is you're going to take the element of this row times the elements of the first column and add them together. That sounds awfully confusing. So the first thing, let me rewrite this a little differently. So we have an A times B, all right? So we have a 2 by 2. So A, B, C, D times E, F, G, H. So the first thing we know, is it defined? This is a 2 by 2 and a 2 by 2. Yes, it is defined because they're the same. They're equal. Our result is going to be in a 2 by 2. So our result is going to be in a 2 by 2, which means you have 2 rows and 2 columns. Now remember, it's RC for the address of the element. So this is going to be 1, 1. This is going to be 2, 1. This is going to be 1, 2, and 2, 2. So remember, the first one first number is the row, and the second one is column. So we're going to take row 1 of, so the rows are going to be taken of the first matrix. Columns is going to be the second matrix, B. So let's take row 1, which is A, B. So we're going to do 1, 1. Or we can call it C because our results can be C. Correct? We can call this matrix C. So these are going to be C, little c's as the address. So AB, and then I'm going to take column 1 of the second of matrix B. All right, so we're going to times E times G. The result's going to be AE and BG, and you're going to take the sum of them. So it's going to be AE plus BG. This is going to go in C11. Then we're going to take the second column, and we're going to do C and D times the first row, E and G, CE, DG. You're going to add them together, CE plus DG. This is going to be C21. And then C12, row 1, AB, column 2, FH, and it's just the product of those. And we're going to add them, so we're going to get AF plus BH. Then we're going to take C22, and we're going to take row 2, CD, and column 2, FH, and then we're going to take the sum, CF plus DH. And this is what's going to go in those columns. So let's do the actual example. It makes more sense when you have numbers. So they want to find x, y, which means the multiplication. If x is going to be 6, -10, -3, -2, and y is going to equal to -5, 3, -4, 3. Okay, so this is a 2 by 2. First thing you need to do, is it defined? Yes, our result's going to be a 2 by 2. We're going to call it C. So we're going to have C11, C21, C12, C22. So those are the elements. You have 4 elements, and those are the addresses. So remember, you're going to take row of the first. This is going to take the rows of the x's and the columns of the y's. That's just how we do it. So let's start with C11. So we're going to take row 1. So we're going to have a 6 and a -3 times column 1. I'm going to put parentheses, -5 and 3. The result is -30 and -9. You add those together, we get -39. So I'm going to come over here. This really needs lots of work. And that's going to go right here. Then I'm going to do C21. I'm going to take row 2, so -10, -2, column 1. This is why I need to stay organized. This can be really messy. So this becomes 50 and -6, which equals 44. Yes, so that's going to go in here, 44. Then I'm going to do C12, and I'm going to take row 1 of x, so it's 6, -3, column 2, which is -4, 3, equals -24, -9, which equals -33. That's going to go right here. Okay, so now I have one left to do. It's C22. I'm going to take row 2 times column 2, -4, 3, we get 40, and we get -6, so we get 34. Here, this is going to be the product of x, y. All right, so if you use my formulas, then you don't have to memorize, oh, what do I need to multiply? Well, find is it defined, find the resulting size dimensions of 2 by 2, put the address, call it whatever you want to call it, a different letter. So the first one is x, so that's going to be the rows and the columns. So remember, this is RC. So you're going to take, for this element, you're going to take row 1, 6 and negative 3 times column 1, negative 5, 3. Find the product and then take the sum of those numbers, and so on and so on. All right, pause it and try guided practice 2, and we'll see you in a second. All right, let's look at the real world example. Now it says, at a particular swim meet, 7 points were awarded for each first place finish, 4 points for second place, 2 points for third. Find the total number of points for each school. Which school won the meet? So here's our problem. So what do we have to do? First of all, we're going to have to take the results, because this is how many first places Central High got. They got 4 and they got 7. That's what this means. 7 second place finishes and 3 third place, and so on. So we have to take this times, for first place, it's going to be 4 times 7, and 7 times 4, and 3 times 2, and then we add those points together. So what we need to do is we need to write this as a matrix times the results times the points. So we're going to have results are is going to be 4, 7, 3, 8, 9, 1, 10, 5, 3, 3, 3, 6. And the points is going to be 7, 4, 2. Now we need to multiply. So we have a 1, 2, 3, 4 by 3 and a 3 by 1. Okay. Are these equal? Yes. So what's our result going to be? It's going to be a 4 by 1. So our result is going to be a 4 by 1, right? So 1, 2, 3, 4. Let's call it scores, S. All right? So this is going to be S11, S21, S31, S41. This is going to be the rows column. This is going to be the rows, and this is going to be the columns. All right, so we need to do 1, 2, 3, 4 multiplications. So our result of 1, 2, 3, 4. This is S, which is R times P. All right. So let's multiply. So I'm going to change a color here. So S11 is going to be row 1, 4, 7, 3 times, there's only one column, 7, 4, 2. So we get 28, 28, and 6, which results in 56, 62. Then we're going to do S21, so it's going to be 8, 9, 1 times 7, 4, 2. So we're going to get 56, 36, and 2, which is 50, 80, 92, 94. And then we're going to do S31, so row 3, 10, 5, 3, and then we only have one column, 7, 4, 2. So it's going to be 70, 26, 70, 96. So we have 96 points here. Then the last one is S41, so we're going to take 3, 3, 6, that's row 4, column 1. So we get 21, 12, and 12, that's 24, 34, 44. We get 45. So these are the points respectively. So Central High School got 62 points, Franklin 94, Hayes got 96, and Lincoln got 45. And the winner of the meet was Hayes High School with 96 points. All right, so pause it and do guided practice 3. Let's now look at example 4. So we're going to test the commutative property. Remember, we said we have it exists matrix A plus matrix B does equal to matrix B plus matrix A. Let's see if it Same thing applies to multiplication. We know in real numbers, commutative property does exist, but does it for multiplication? Does it exist for multiplication matrices? So we're going to find the product of GH and HG. So GH is a, G is a 2 by 3, and H is a 3 by 2. Is it defined? Yes. The result is a 2 by 2, correct? So we're going to do a 2 by 2. So 2, 2, 2, 2 rows, 2 columns. And this is going to be 1, 1, 2, 1, 1, 2, and 2, 2. So remember, the first one is going to be the rows. The second one is going to be the columns. So we take row 1, so I guess I should write these out. So you have 1, 3, negative 5, 4, negative 2, 0. This is G, and these are going to be the rows. And then H is equal to 2, negative 2, 1, 3, negative 8, 7. And these we're going to use the columns. So row 1 is going to be 1, 3, negative 5. Column 1 is times 2 times negative 2 times 1. We have 2, negative 6, negative 5. Take the sum, negative 11, so it's negative 9. So that's going to go right here. Then I'm going to take row 2, so 4, negative 2, 0, times column 1 times 2 times negative 2 times 1, 8, 4, 0, 12. That's going to go right here. Then I'm going to do 1, 2. So 1, comma 2. I guess I should label these 2, comma 1 and 1, comma 1. All right, so 1, comma 2. So row 1, 1, 3, negative 5, column 2, times 3 times negative 8 times 7. I'm going to get 3, negative 24, negative 35. I'm going to take the sum of these, and it's going to result in negative 56. That's going to go right here. I have one left to do, which is 2, 2. So row 2, 2, 2. It's going to be 4, negative 2, 0. I love zeros. Column 2, 3, negative 8, and 7. So it's 0, 16, 12, 10, 28. Okay, so this right here is a product of GH. Right, so let's remember that. Now let's do HG. All right, so we said H is a 3 by 2, and G is a 2 by 3. It is defined. Result is going to be in a 3 by 3. So we're going to have 1, 2, 3, 1, 2, 3, 1, 2, 3. Let's write the addresses. So this is 1, 1, 2, 1, 3, 1, 1, 2, 2, 2, 3, 2, 1, 3, 2, 3, 3, 3. So remember, we're going to take the rows of H now and the columns of G. Okay, got to keep them in order. You can't just decide to switch them. So row 1, 1, I'm not going to write these. You can look on your paper for column for H. Remember, rows for H is going to be a 2 and a 3. Oh, I got this wrong. Okay. H is a 3 by 2. This is a 2 by 3. Yeah, that's right. So R1, row 1, oh, okay. So row 1 is 2, 3. Column 1 is times 1 times 4. See, I really need to write this down. And the sum is 15. 1, 2, 3, 1, 2, 3, 1, 2, 3. So it's going to go right here, 15. Or 14. I did some bad math somewhere. It's 14. I did do bad math. And then the next one, 2, 1. So it's -2, -8, and 1, and 4. I get -2, -32. I get -34. -34. Well, first of all, the other one, our result of GH was a what? It was a 2 by 2. This was our result. -9, -56, 12, 28. They're not going to be the same. Isn't this a 2 by 2? And we don't even have to go any further. We can, but we're not going to. So this right here is a result of HG. This is GH. They are not equal. Therefore, the commutative property does not exist for multiplication matrix. It can, but it's not a property. It's not one that says, yes, you have the multiple. It applies every time. Sometimes, depending on dimensions and the numbers, they could be the same. But you can't, that is not a property. So does the commutative property of multiplication exist? No. Could it work out sometimes? Yes, but the property does not exist. That is important. Okay, let's look at 4. Example 4, determine, it's a guided practice. So try the guided practice. So determine if AB, the product of matrix AB, equals the product of BA. So you're first going to find the dimensions of each one. They could be the same. Doesn't mean that they're equal, correct? And then you have to actually multiply and get the result and see if the numbers are exactly the same. So pause this and try guided practice 4. We have one more example to look at. It says find each product if J is this, K is this, and L is this. So what are we going to do here? We can use order of operation, which means inside parentheses, so we would add K plus L, and then J, we can multiply J by the sum of K plus L. So let's do that. So let's write our matrices. You have a 2, 4, -5, -2. Okay, times 3, 2, -1, 3, plus -4, -1, 3, 0. All right, so first thing we're going to do is we're going to add. This is a 2 by 2. We have to see if it's defined. Yes, they have to be the same to add, so we're just going to add. So I'm going to rewrite this because this is what we're going to do next. So 3 plus -4 is -1, 1. Hello? 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 Okay, so sorry about that. So then we multiply. So how do we multiply? Well, you have a 2 by 2, so the result's going to be a 2 by 2. 2, 1, 2. This is what it's going to equal. So it's 1, 1, 1, 2, or 2, 1, 1, 2, and 2, 2. All right, so that's the result. So we're going to take 2, 4 times -1 times 2, -2, 8. We add them, we're going to get 6. And then we're going to do 2, 4 times column 2. It's 2 and 12. It's 14. So we're going to get 14 right here. And then we're going to do the next one. We're going to get 1, and then we're going to get negative 11. So this is j times k plus l. Now, if we do jk times kl, so we do jk plus jl, all right, we're going to take the 2, we're going to distribute. So originally this is what we had, k plus l. We're going to distribute, and we're going to do jk plus jl. I'm not going to do the work. We can look in the book. So let's look at the book and look at the steps here. So we just did a different way. So we tested commutative property. Now what we're testing is distribution property. Whoops, went too far. So we look at here, they do the work, and we notice that we get the same result. So we can say that j times k plus l is equal to, if we distribute it and did jk plus jl. So the distribution property does exist for matrices. So stop this, try the guided practice, and then we'll see you in class.